Hi children, we continue with our second chapter, acids, bases and salts. In the last class we started this chapter and we just introduced the, went to the introduction of the chapter, that is the basic difference between acids and bases and how indicators are used to distinguish between acids and bases, and also we saw the different types of indicators which are used, like synthetic indicators and natural indicators. Now we move on to the next topic of the chapter, most important topic of this chapter, that is chemical properties. Chemical properties of acids and bases. Chemical properties of acids and bases. Under this heading we have to learn about three different kinds of reaction. First one is reaction with metals. We will see how acids and bases react with metals. Let's start with acids. How acids react with metals. Okay. So separately we have to see how acids react with metals and how bases react with metals. Okay. Now acids react with metal to form salt and hydrogen gas. So generally acids react with metals to form salt and hydrogen gas. And when you say metals, these are active metals. In the last chapter under displacement reaction we discussed the reactivity series, and I hope you remember it. Series in which metals are arranged in the decreasing order of their reactivity. Actually it is a series of metals, and I told you in that series there is hydrogen. Hydrogen is also included in that reactivity series. Now hydrogen being a non-metal, why it is included in the reactivity series is it is just used as a standard. Metals that have high reactivity come above hydrogen. Metals of low reactivity like copper, mercury, silver and gold lie below hydrogen in the reactivity series. So when we say active metals, these are the metals which lie above hydrogen in the reactivity series. So you have to learn that series, reactivity series, by heart. There are actually 8 metals above hydrogen in the reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron and lead are the 5 active metals, or the metals which lie above hydrogen in the reactivity series. These metals are capable of removing hydrogen from acids. For example, we will see sulfuric acid. In place of acid we will write the strongest acid, that is sulfuric acid, and the metal zinc. Zinc is an active metal. Where is the position of zinc in the reactivity series? Zinc lie above hydrogen in the series. So it is active metal. It is more reactive than hydrogen. Then what happens? The position of hydrogen in this acid will be taken up by zinc, and you get zinc sulfate. So hydrogen is displaced. Hydrogen is removed by zinc. So this is an example of displacement reaction. Hydrogen being less reactive than zinc is replaced or displaced by zinc, and you get the salt, zinc sulfate and hydrogen. And now coming to the naming of salt. When you say the name of the salt, the easy way to find out the name of the salt is first write the name of the metal. First write the name of the metal. Here the metal is zinc. So we start with zinc. Second part is taken from the acid. Second part of the name of the salt is taken from the acid. So if the acid is hydrochloric acid, the salt formed will be chloride. The salt will be chloride. If the acid taken is sulfuric acid, the salt formed will be sulfate. If the acid taken is nitric acid, the salt formed will be a nitrate. So that's how we name the salt. That you have to keep in mind. Here it is zinc and sulfuric acid. So first part is name of the metal, so it is zinc. Second part comes from the acid. Since it is sulfuric acid, we write as sulfate. That's how you get the name of the salt, zinc sulfate. Or this hydrogen of the sulfuric acid is replaced by an active metal zinc. So hydrogen is displaced hydrogen gas is formed. A place of hydrogen is now occupied by zinc. That's how you get zinc sulfate. So acid react with metal to form salt and hydrogen gas. Okay, one more example we will write with hydrochloric acid. Let us write another active metal. Position of magnesium in the reactivity series is above hydrogen. So it's an active metal. So it is definitely capable of removing hydrogen from hydrochloric acid. Okay, so hydrogen is displaced and you get MgCl2. The position of hydrogen in the acid is now occupied by magnesium and you get magnesium chloride. The displaced hydrogen gas is formed here. Okay. Now another example with sulfuric acid we will write. So sulfuric acid reacts with, sulfuric acid is the strongest acid. This is the highly reactive, most reactive metal, potassium. So let us see the products formed. So how you write the name of the salt? First write the, when you say the name of the salt, first the name of the metal. So potassium. Second part come from the acid. So the name will be, since it is sulfuric acid, it will be sulfate, potassium sulfate. What is the formula of potassium sulfate? K2SO4 plus H2. Okay, so this is the balanced equation for this reaction. I hope it is clear to you. So metals react with active metals. Active metals means metals which lie above hydrogen in the reactivity series to form salt and hydrogen gas. All these metals are capable of displacing hydrogen from the acids. So these reactions are examples of displacement reaction. Hydrogen is being displaced by the metal. So all these are examples of displacement reactions. Okay. Now what is the test for hydrogen gas? How will you test? The gas hydrogen is colorless, odorless gas. It has no particular color, no particular smell. So how will you identify it as hydrogen gas? So we don't have any evidence that it is hydrogen gas. One gas is coming as bubbles. It has no color, no smell. So there is a test to identify whether it is hydrogen or not. This test we have learned in smaller classes. What is the test for hydrogen gas? Bring a burning candle or matchstick near the mouth of the test tube. We have to bring a burning candle or a matchstick near the mouth of the test tube. So if the evolved gas is hydrogen, it will burn with a blue flame and a pop sound. Okay, so that is the test for hydrogen gas. Bring a burning candle or a matchstick near the mouth of the test tube from which the gas is evolving. So if the gas that is coming out of the test tube is hydrogen, it will burn with a blue flame and a pop sound. So it confirms that the evolved gas is hydrogen. So this is very important. How metals react with, how do metals react with acids? Active metals react with acids to form hydrogen gas. How will you test for the evolved gas? Test for hydrogen, you have to write there. Bring a burning candle or a matchstick near the mouth of the test tube. If the evolved gas is hydrogen, it burns with a blue flame. Gas burns with a blue flame and pop sound. It is not the matchstick, it is the gas which burns with a blue flame and a pop sound. So that confirms the presence of hydrogen. Okay, so I hope it is clear to you. And how to write the name of the salt? Metallic part first, then second part is from the acid. Depending on the acid, you have to write whether it is chloride, sulfate, nitrate, etc. So it depends on the acid that is taken. So you can write for any example, any reaction, you can write the product. One is definitely hydrogen, the other product is salt, that you have to write in the way in which I told you. Okay, so these are displacement reaction between acids and metals are examples of displacement reaction because hydrogen is being displaced by the active metal. In that context, you have to learn activity 2.3 and figure 2.1 from page number 19. In your NCERT textbook, page number 19, activity 2.3 and the figure related to that, figure 2.1, you have to learn from your NCERT textbook. That is actually the reaction between zinc and sulfuric acid. Okay, zinc granules and sulfuric acid, the same reaction. Okay, that reaction is explained with the help of an activity. The evolution of hydrogen gas is shown there, and how the hydrogen gas evolved is tested with a burning candle. That is also shown there. So this is a previous board question. So learn it from the textbook, that activity, and also the diagram from page number 90. Reaction between zinc granules and sulfuric acid resulting in the evolution of hydrogen gas, and finally how is hydrogen gas tested. Important question, and you learn it from your textbook. Okay. Now we have to see how bases react with metals. Not all bases react with metals. Only strong bases like sodium hydroxide react with active metals like zinc upon heating to form Na2ZnO2. This is a new kind of salt for you. The name of the salt is sodium zincate. Okay. So active metals like zinc react with strong bases like sodium hydroxide upon heating to form salt sodium zincate and evolution of hydrogen gas. Here also the test for hydrogen is same. Which gas is evolved when metal react with an active metal react with bases like sodium hydroxide? Gas evolved is same, hydrogen gas. So the test for the gas evolved is asked. Same test you have to write. Test for hydrogen, bringing a burning candle or a matchstick near the mouth of the test tube, that you have to write there. Okay. It's an important reaction. This is also a previous board question. Reaction between sodium hydroxide and zinc to form sodium zincate and hydrogen gas. The name of the salt, you have to learn it by heart, because about these kind of salts you will learn in higher classes. 11th and 12th standard you will learn about these salts, but time being you just learn its formula and the name. Sodium zincate, Na2ZnO2, sodium zincate plus hydrogen gas. So this is the only reaction that you have to learn under bases and metals. Reaction between bases and metals, there is only one reaction that you have to learn. Only this reaction, sodium hydroxide and zinc to form sodium zincate and hydrogen gas. Okay. So with that, first reaction is over. Reaction of acids and bases with metals is over. Both acids and bases. Finally hydrogen gas is evolved. Metals, acids and metals we have to learn more examples. Bases only one example is there. Test for hydrogen gas is very important. Okay. So now we move on to the second reaction, that is reaction with. This reaction is undergone only by acids, not bases do not undergo this reaction. So reaction of acids with metal carbonates and metal bicarbonate. Metal carbonates and metal bicarbonates. Bicarbonates are actually metal hydrogen carbonate or metal bicarbonate. Okay. So this is the second reaction. Reaction of acids with metal carbonates and metal bicarbonates, or metal, instead of bicarbonate in the question sometimes it will be metal hydrogen carbonate. How acids react with metal carbonate and metal hydrogen carbonate. So general equation I will write on the board first. So acid plus metal carbonate, or same product we are getting for metal carbonate or metal hydrogen carbonate. Whatever you are taking, product will be the same. The difference will be only in the balancing part only. So you will get a salt, carbon dioxide plus water. So whether it is a metal carbonate or a metal hydrogen carbonate, product obtained will be salt, water and carbon dioxide gas. So these are the products obtained when an acid react with a metal carbonate or a metal hydrogen carbonate. This is an easy reaction, but the equation you have to be careful. Okay. So we will write the example for this. Na2CO3. So this is a metal carbonate. Sodium is a metal. Carbonate of a metal, sodium carbonate. reacts with acid. Okay, reaction between a metal carbonate and an acid. The product here will be salt NaCl plus CO2 plus H2O. So, metal carbonate, sodium carbonate react with hydrochloric acid to form sodium chloride, carbon dioxide and water. These are the product obtained. This is the salt here. Metal here is sodium. So, the name of the salt starts with sodium. Second part comes from the acid taken, that is hydrochloric acid. So, it is chloride. Sodium chloride is the salt. Other two products are already given in the general equation, carbon dioxide and water. Now, with the same metal, hydrogen carbonate, we will write the equation. Metal is the same sodium. Sodium hydrogen carbonate, it is simply known as sodium bicarbonate. Sodium hydrogen carbonate or sodium bicarbonate reacts with the same acid HCl, hydrochloric acid. The products are the same actually because the metal is sodium. So, sodium chloride, acid is hydrochloric acid. So, sodium chloride is the salt form. There is no change in the salt. Other products are also same. So, the difference is only in the balancing of the equation. Okay. So, whether you are taking sodium carbonate or sodium hydrogen carbonate, when it reacts with hydrochloric acid, we get the same products, sodium chloride, carbon dioxide and water. Now, we will write an example with another acid. So, with magnesium carbonate and magnesium bicarbonate, we will write. Okay. This is magnesium carbonate, a metal carbonate. Same metal bicarbonate, magnesium hydrogen carbonate plus, instead of HCl here we will take sulfuric acid. So, in both the reactions, products are the same because metal is the same, acid is the same. So, difference is only in balancing, products are the same. You will get Mg. Magnesium is the metal. Since acid is sulfuric acid, it will be a sulfate. Magnesium sulfate plus carbon dioxide plus water. Here it is same products, MgSO4 plus CO2 plus H2O. The difference is only in the balancing. Here it will be difference is only in the balancing. So, you get magnesium sulfate, carbon dioxide and water. Here also magnesium sulfate, carbon dioxide and water. That is 2H2O, 2CO2. So, that is the only difference there. Okay. So, the gas evolved here is carbon dioxide gas. So, carbon dioxide is also a colorless, odorless gas. So, how to identify whether the gas evolved is carbon dioxide or not? There is a test for carbon dioxide that you have already learned in smaller classes. Test with lime water test. Lime water test. The gas evolved is passed through lime water, calcium hydroxide. So, it changes to, if it is carbon dioxide gas, when it is passed through lime water, a milky appearance will be produced. Lime water will become milky due to the formation of calcium carbonate. So, the test for carbon dioxide gas is pass the gas through lime water. If it is carbon dioxide, lime water will turn milky, and the milkiness is due to the formation of calcium carbonate. This is the equation for that reaction between carbon dioxide and lime water. This reaction you have learned in 7th standard. Okay. So, this is the second reaction of acids with metal carbonate and metal hydrogen carbonate. In both the reactions, we get the same product, salt, carbon dioxide and water. And the carbon dioxide formed can be, since it is colorless and odorless, it can be tested with lime water. It turns the color of lime water to milky due to the formation of calcium carbonate. Okay. So, today In this class, we can discuss only these two reactions. The other reactions of acids and bases we will learn in the next class. Okay.